Okay. We talk about data analytics. Definition is what data analytics is the process of analyzing raw data. And if you remember, we talked about the raw data last time. If you go to a social media, and you copy the comments, it's a raw data. If someone send you just a data like this, it's a raw data that you have to know how to make it useful and get draw out of it a meaningful insight. Um, like they said, the insight are then used to determine the best course of action. What does it mean? It's help now to do something meaningful for the corporate. Remember, as a data analyst, what we do, we just take their data. They know their data better than us, but they don't know what to do with their data. Either is a marketing company or is a sales company like Walmart. Uh, Walmart want to sell a new product to, so they have a record. They have been doing Walmart have been there for years and years and decades. So they want to sell and they want to optimize their marketing strategy at this time. They want to strategize their marketing campaign. So as a data analyst, they will ask you how they can come up with the best strategy to do that so they can have a save time, save money. Most of our work, we save time and save money for the client. And that's why they pay us a big bucks. And we know American is a capitalist country. It's money, money, money. You bring money, they will give you your share. So you have to locate if it's um like appliance. You got to figure out which area or what people like. They bring Tesla now. Tesla is out and Tesla want to do a marketing campaign. If you bring Tesla into Southeast DC, probability they are not going to buy your Tesla because this is one example. I have nothing against the Southeast DC, but I'm trying to give this example. It's area. Their income level doesn't match uh, to pay the car loan for Tesla or to maintain Tesla. And also, Tesla is a car that doesn't have, and you don't put gas in it, but you have to install or you have to charge it every day, almost every day or every 2 days. So you have to know the area or the group that will be able to afford Tesla to direct your marketing campaign into them. There's some areas where you know that area contain middle class. And when we talk about middle class in America, is between household income between 100,000 to 150, 160, 200, 250. So those people can afford that type of car. If you are building a house in an area and where you have other houses like 100, 200, 300,000, or say you want to build a house of 5 million on the middle of the, you're not going to sell that house. So we do those analysis for them to be able to make the right decision, and we give them recommendation also, and they base on our recommendation to carry out their marketing strategy or the decision that they want to make. They already have something in place working for them for a year. We are coming to optimize that. So we are bringing something that will improve their process and save them money and time. So we get what they have in the past. We call it I'll come up with it. The data that they have, historical data. Historical data, it means that they what they used to do, what they have been doing. You take that now and now you analyze it and see how you can improve their process through that. Okay, here they say there are a range of method and technique that data analysis use depend on the type of the data indication and the kind of insight they want to uncover. From here, I'll tell you as a data analyst, we are open to work in any field. That's one of the advantage we have. You can work in the um, car industry, sales industry, government contracts. You can work in the medical field. You can work in the finance. Everywhere they need data analyst or data scientist or data engineer because they have accumulated a lot of data sets that they need to analyze those data and see the insight they have and how can they use those insights to improve their process. Okay, data analysis. A credible amount of data must be collected to allow for a substantial analysis. What does it mean? You see, last time I showed you a data set that we work with, like this data set here. You can base on this data set and do a prediction because a data set is too small. Uh, so by using this data set is kind of limited. A, rather, you use this type of data set, then you know, okay, the probability of getting the right thing is is big. They have the sample data that is large. It's like if you take only a handful of data, handful of people, 10 people out of billion of people, and you want to use them to represent the whole nation, it won't work because the probability is that they may be the same people, or they may be doing the same thing, or they may be in the same area, or their result or their attribute may not reflect the whole nation attribute. That's what is being seen here. A credible amount of data must be collected to allow for a substantial analysis. We need a lot of data. If you go to interview, they will ask you this question: what's the size of the data or the volume of the data you have worked with, the largest or the biggest fast? Because they want to know if you really work at the corporate level or enterprise level, or you are just using uh, Udemy or small data set right and left to play and train yourself to become a data set, a data and data analyst. Information collected must now be described, analyzed, and interpreted. That's what I said before. You have to be able to collect enough data, and when you collect them now, you have to use your statistic knowledge to describe them, analyze them, and now interpret them. If you go to interview, this question may come: how do you interpret your data, your result to a not technical person to understand? You have to be able to break your result down to anyone to understand. You may think that they may understand because they are well educated than you, they have highest degree, but they are not in your field. they may not understand when you talk about percentile, when you are talking about error margin, all those things, p value. They That's not their language. Their languages is business. How much can you save? What do you see in our data? Just like a five grader, explain it to them. You must look beyond the raw data to ask important questions about what the result mean and whether they are significant. When you have a data set, a large data set, like this data set that I just show you, something like this, it become challenging for you because all the field have just numeric data, only one has string data here. Now, even the string, you can see they say, what did they say? Diagnostic diagnosis. And you have MMMBB, MMBB. What do you know about MMBB? What does it mean? They don't have data dictionary to explain it. There's nothing to explain to you what this field mean, what the ID, what is it? Is it ID for what? Client or radio? So you have to ask number one the question to know if they have a data dictionary. A data dictionary will explain all this field to you so you know what each field mean and how to use them. Now, number one, we have about 12, 13, 14, 15, 16, 17, 18, 19, 26, 26, 27, 8, 9, 10, 11, 12. You have about 30, 36, 38 column here. We call them field. Sometimes they call them parameters. Now, this that we have here, how will you know if you need to use all of them or you need to use only two or three or five or 10? That's one of the challenge that we will go through as data analysts, data scientists. Here, you have to ask the question to know if they don't have data dictionary. Ask them now what those field mean. Each field, and take a note. Most of the time, it's better to write email and ask. When you are on a project, they will give you someone that will work with you within the company who knows the company well, who know the business well. So any question you need to know about the data set or the business, you go to that person. Always ask to send email, because if they email, you have the record that if tomorrow they say no, that's not what we tell you, you have the email to prove that no. I asked you this question, that's what you told me, and that's what I did. Ask important questions about the result, meaning of what you have. After asking the question, you have to write your use case. Use case is what? Rephrase the problem, because you are solving a problem for them. Rephrase the problem the way you understand it and send it to them and ask them if that's what they want, or out of your conversation with them, that's what you pick out. Is that true? And they will ask, they will say yes or no, or yes, but this one, this area is not like this, and this area is not like that. Then, because if you don't communicate with them and you get this type of data set, it's gonna be complicated for you, and you come up stupid because you don't know anything about this data set. When you have this type of data set, do you really know what they want you to do? You have undergraduate, major, starting, no. You have no clue what they want. They want to solve a problem with this data set. What problem are they having? What problem they want to solve? Do you need to ask those questions? And we will go walk through all those things. Another data set here. You have the status agency. You have all these things. What exactly they want to do with this data set? It's a large data set also. But what exactly can come out of this data set? You have to understand, ask question, and gather your information before you start your work. You must check the data to ensure that it is clean and look for inconsistency. When we talk about inconsistency and clean data, is what is mainly what you guys start doing it in Excel. You have to make sure that the data doesn't have a duplicate. What is a duplicate? We will work on it. Is when you have, for instance, a data set in this side, and you have same thing over and over and over. It makes your result not accurate because we have a repetition of the same thing, or sometimes the columns are the same. You have to make sure that you delete some, and you have to make sure sometimes you have, we call some stuff missing data. The missing data, they are empty. How to work with the missing data, all those things we work on it during the process. So after working on a data set now, you see, you collect a large set of data. You now describe the data and interpret it, do your analysis here. And now here, the role you ask the important question now. This one should come before this one. This one should come before this one. And now, when you finish, now before you start your work, you have to make sure that your data is clean and look good to do your work. Okay, method of data analysis. We have regression analysis, Monte Carlo simulations, factor analysis, cohort analysis, cluster analysis, time series, sentiment analysis. These are various areas of uh, of machine learning and analysis that we do. Just give me 1 second. Uh, Mr. Gaston,
Yes.
yeah, I will steal at least 20 minutes of your time today. Okay.
Okay. Okay, no worries.
Okay. Thank you. Okay. So when you have all this analysis, you have to know which one your data fall into, or which one to use for your data, and which one can solve your problem for you. It's not like you have to use all the method at once. You select the one that is appropriate to your problem that will give you the answer. Yeah. Now, data analysis, we deal with a quantitative and qualitative method to produce different type of data. We have the, so far, do you have any question? Okay. We have the quantitative data that produce numerical value, quantitative, numerical, qualitative data produce narrative. But for both quantitative and qualitative data, the same analytical strategy are used for data interpretation. One thing you got to know is a little complex to work with qualitative data. Quantitative data is easy, straightforward, but qualitative data is kind of complex because of the way our computer chips interpret the data. Behind they have 001, 001. So when we give them the qualitative data, they have to now translate it into machine languages before they can give you the result. So we have techniques to do that behind the scene to get the result. What is the difference between quantitative and qualitative data? Quantitative data is anything measurable comprising specific quantity and numbers. Quantitative data analysis technique focus on statistical, mathematical, or numerical analysis, usually large data sets. Qualitative data cannot be measured objectively and is therefore open to more certain interpretation. If qualitative data analysis, the focus is on making sense of unstructured data, such as writing text or transcript or spoken conversation. Often, qualitative analysis will organize the data into terms, a process which fortunately can be automated. What does it mean? As a data analyst, they can give you a text, a writing text to analyze. They can give you a transcript, a spoken word. They can give you video. They can give you um, anything to image. You have to know how to analyze all those things. For instance, if they give you data set like this one, you have to know what is inside, what to get out of this, and how to analyze it and come up with a result for the client. Maybe all you need is the data field here. Analyze them, come up with the most useful word, or compare the term that they have in. That's what we call natural language processing. Natural language processing. Okay, data analysts work with both quantitative and qualitative data. So it is important to be familiar with a variety of analysis methods. When you come here, you have easy quantitative data that you can just go straight forward and do the analysis. Same here. Same here. But now you have a problem with this field because all the fields are numerical and only in this one. So if you have been given a data set like this, there's two things you can do. Filter this one and see if only you only have A, no, B, and M here. If you have other stuff, all you can do, group them. And that's what we call clustering or grouping, depend on the tools you are using and what you are looking into the data set. And now I'm not going to go far for regression today, but I'm going to jump because I have 10 more minutes so we can go into the basic of statistic after I show you the data set, different data set that you will be working with. Statistic is a branch of mathematics dealing with the collection, analysis, interpretation, presentation, and organization of the data. Statistics cover data to information. If you follow well what we went through here, we were saying that the data is the process of analysis raw data to draw meaningful insight here. You see this one here, and here we talk about collection of the data and all those things. And what do we use to do all those things is statistic. Okay. Here we have two areas of statistic. We have the descriptive statistic, which is the summarize of the data, population data set. You have to describe the data. That's what we use descriptive uh, statistic. We have inferential statistic. It's based on random sample from population. We have the, if they want to do some analytics now, they can get a feedback or a survey from all 330 something million Americans. It's gonna be very hard. It may never be happen because some people will never participate into the survey. Some people who always procrastinate. Oh, I'll do it tomorrow. So that result will never come. So what they do, they take a sample of the data. They can base on only 1 million or 2 million or 3 million, depend on the set that they decide upon. So we call that sample data. So you hear sample data and population data. Those two things are mainly different. The population is the whole data set, and the sample is a handful that they take out of it to do the analysis to represent the whole population. Now, out of this, we have the qualitative and the quantitative that come back here again. The data, we have qualitative data, which is the descriptive car brand category, automatic, manual, gear. The quantitative data is the weight of the car. The car weight maybe 20 pound, 100 pound. Mile per gallon, horsepower. Those are the quantitative data that you receive. Both can be the same and that composed of the one data set. Now you use the qualitative data to describe the data that will give, and the quantitative data will give you the result. We will do it, and then you see the result. The qualitative and the quantitative, what is the difference? Continuous data and discrete data. The infinite category and finite category. Weight of a car is infinite. Mile per gallon, horses. But number of gear, automatic, is either manual or automatic. Automatic or manual, one of the other. The gear of the number of gear is maybe first, second, third. But weight of car, every car has a different weight. Mile per gallon, every car has the different mile per gallon. Horsepower, every car has, and you have a lot of cars. So if you want to describe, it's infinite. There's no one set weight of all cars. Some car may weight maybe 20 pounds, some 100 pounds. It depends. So it's infinite. Continue. Now, the measurement, we have the data, which is we have nominal, ordinal, interval, and ratio. In the nominal, we have example of the color: blue, green, yellow. Those are nominal. With nominal the data, the measurement. And we have the ordinal, which is the pass or fail, good, bad, worse. And we have the interval example: temperature, Celsius, and Fahrenheit, and all those things. And we have the ratio, which is weight, height, mass, volume. All those things are in the ratio. And the measurement, you can see that when we have nominal data, the order is we don't have it can, or the order of data, don't, they are not nominal, they are not ordinal, They are not interval, but they are ordinal and interval and ratio. The difference, they are not nominal, they are not ordinal, but they are interval and they are ratio. And absolute zero is nominal, non-nominal, or not ordinal, not interval, but they are ratio. For example, uh, blue and red, they are not nominal. So all you can get from them is the mode. What is the mode? We're gonna go through it before I have 10 more minutes. Uh, Ordinal, we have good, bad, worst. With that, we can calculate the mode and the media. For the interval, we can we have the temperature and degree Celsius. For that, we can calculate the mode, the median, and the mean. Now, for the ratio, length, weight, which is no numerical, we can calculate the mode, the median, and the mean. All these are descriptive statistic. Same, you can see the nominal and the ordinal are qualitative data, and the interval and the ratio are quantitative data. Now, I'm going to jump into stuff. I was telling you about the sample data and the population data. When you see capital N is a number of members, which is the population. The small n is a sample, it represents the sample. The mean, you have this representative for the population because you may see them in some of your description and you have to know what they mean. They may not put mean, they may put this X in a formula somewhere for you, or this one. When you see this one is a population, when you see this one, if the bar is the mean, and standard deviation is this, and for the sample is this. Just to know, I'll give you this so we can refer to it. Now, descriptive statistic, we have central tendency, which is the mean, mode, median, and percentile, and variability, which is the range, standard deviation, and the interquartile range. Next week, we will go through them one by one to well explain them. Okay, I'll jump into the mean. What is the mean? The mean, sometimes they call them average, but these days they don't call them average. You won't hear average anymore like you used to. It's mainly mean. Is and here they say is affected by extreme value. What do they mean by that? You got to be careful when you are using the mean. Assume that we want to get the salary of a certain area, maybe my area here, and it's a middle class here. And middle class, as I told you, is between 100 and maybe 200,000. And it happened that um, some businessman, entrepreneur, they love the area and they come they're in the area. And there's five of them. And those five, their yearly income or their revenue is over 20 million or 30 million. So if they want to know the average salary of our area, those numbers will affect because when you add 20 million 20 times, you see that the average income may be going maybe into 300,000, 500,000, or millions. But that's not, it's only a handful of people that has that $1 million that influence or affect the whole range. Why and how is that affect? You see here the example. We have 10, 11, 14, 9, and 6, right? And now you have the mean. The mean is what? The sum of all the numbers divided by the number of items, and that's what gives us the mean. Now we have 10, 11, 14, 9, 6. Total of it is 50. Now the number of items 1, 2, 3, 4, 5. We have 5 items that give us, we divide the 50 by 5 and give us 10. Here's the example here. We have 10, 11, 14, 9, and 6. Now, if I add all of them, it will be, let me do it here. Okay, let me come back here and do it. It is sum of A2 and E2, right? Now I want to divide this one by 5 because I have 1, 2, 3, 4, 5, 8, 10. And I say this is a 10. You see? But now let me add another number here, which is maybe thousands or 10,000. And now I come back here and I say instead of E5, I'm gonna add F2 rather to it. And you see that the 10,000 here affect the average. You can see that all these 10, 11, 14, 9, 6, and suddenly we have something like a 10,000. It affect the whole thing here. Now, let me do this. Let me bring this to 100. You see that it's meaningful. So here they are saying that the extreme value, it can be the smallest value, it can be the highest value. It will affect it. So when you want to represent your data set or your result, make sure that the mean doesn't come in immediately. Look into your data set and make sure that there's no extreme. We call them outlier when we are doing our analysis, when you do machine learning or those things. Those affect the result in a way that we give the wrong impression, the wrong result to the client. So when I come here, for instance, I have 100 here and I have 110,010 there, and I have this one here, and I have 45 here, and I have these two here. You see now that all these two affect now my data set, that I should be in the, let's see here. Now these two now become a problem for my data set now. So you watch them and how you represent your data set. Okay, Excel has a formula. Excel formula, hold on. Excel formula is here. We use the average in Excel, average of all the column. It does it for you automatically. Here I used a manual. Manual is when you tap sum and you add all the field and you divide by the number of items. But with Excel, as you are doing Excel, we're gonna do the same thing with Python also. That's why I allowed you to do Python for 2 weeks, and the next week I'll have time also. You'll be advanced, so we can do this thing here. So you see average of these two, how to get the average, and you get to the data, and you get this thing. I'll show you next week, because now we jump into the next one. That's the problem we have with the mean. The extreme affect our value. So watch out for the extreme. Now let's go back to the mode. Mode, we have the number that must occur number in our data set. Here you see we have 10, we have 11, we have 14, we have 9, and we have 6, and we have 10. And you can see that the most secure is what? Is 10. Automatically, 10 is the most simple. In our example here, the mode, when we trying to figure out the mode, we have this one. Automatically, we know the one that occur. But let me change something here and see how it's gonna work. I'll put 11 here because we have 11 somewhere. You see that it's keep giving us 10, not 11, because we have 11, 11, 10, 10. And I will tell you next week why it kept the 10. It didn't change it to 11. Just because the first one that it just go randomly, not sequentially. And the first one that it made, that's what it represent for you. If I come here and I put 11 here, it go to 11 because 11 predominate now 10. If I come here and I put 6 here, 16, 6 here, and I come back here, I put 11 here, and you can see it will take 11. Let me even change this one to 10. It will keep the 11. If I change this one to 10 and I change this one to 11, it will keep my 10. The first one that meets the criteria will be represented here. Now, let's go back to the median. The median is the middle value when you put all your item in ascending or descending order. We have 10, 11, 14, 9, 6. When you put them in ascending order, it's what? It starts with 6, 9, 10, 11, 14. So automatically 10 is the middle one. Okay. Now, when we face two middle numbers, what do? In this case, we have 10, 11, 14, 9, 6, 11. When you reorder it, we have 6, 9, 11, 11, 11, 14. And we have to add the two middle numbers. And now divided by 2, which is 10 plus 11, 21, divided by 2 is 10. 10 and a half. Okay, I won't go furthermore because we are not going to do all this calculation, but just to show you how we come up with this calculation, how we come up with the calculation that are behind the median, the mode. We will go to percentile and others next week because our past is time already. For the homework, I'll send you this data set, simple data set, and you'll find me the salary, the starting median salary for each field, and also their, you see here, we only have the median salary. We have the median, so I don't need this one again. They already pre-work that in for you. And we can use this one. Now, group them and find the median, base salary, the overtime. Give me the salary of these people. Find me the average of every column, the mode, and the median of every column. It's a very large data set. And if you have any problem, I'll put it in the statistic field here. You'll see it. If you come here and you come to PowerPoint, you see statistic. What is a statistic? Oh yeah, statistic. I'll post it here, and I'll put the recommended the homework here for you and the data set here for you to see. And trying to do it. Those are the basic data, and we're gonna work with that data next week to go deep into percentile and other stuff. Thank you all for your time today. I really appreciate it of you and wish you good luck for the rest of the class.